Hello everyone, this is the recording for week 5 in IS219. The reading this week are chapters 10, 11, and 12. The discussion is how do you know performance of a database is good? What are some tools that you can measure performance and provide an in-depth look into the troubled areas? Please provide at least one tool and find and explain what it does and what it provides to assist with database and query training. Don't forget your APA reference and in-text citation, and reply to 2 others on Sunday. The initial is due Wednesday, like always. The week 5 assignment is due Sunday. You're to complete problems 1 through 3 on pages 586, which is at the end of chapter 12. Problem 1 is based on the figure. So this is figure P12.1, and it shows you that it has 3 sites, and these are the databases. Now the product database is divided into 2 fragments, and they're in different sites. So for the first question, you're to specify the minimum types of operations that the database must support to perform the operations listed. So you will specify if it is a remote or distributed request or a transaction. The key to each answer is in the number of different data processors that are accessed by each request or transaction. A remote request lies in a single SQL statement. Access the database that are to be processed by a single remote database processor. A distributed request lets a single SQL statement reference data located at several different local or remote data processors. A remote transaction is composed of several requests, and they access data at a single remote site and then a distributed transaction can reference several different local or remote. So, for instance, select from customers. So first you're going to decide, is this a transaction or a request? Well, there's only one statement, so it would be a request. And it's from customers, and customers is only in site A, so it's only remote. It's not distributed because it's only in one site. Now, if it had been product, it would be distributed because product is broken up, so that would be distributed. Also, sometimes it can be a remote. You'll need remote request along with a remote transaction or maybe a distributed transaction. So you look at each one, determine where it's going to by looking at the table. And then you decide, okay, is it a single statement? If it's a lot of statements, maybe the one request is only to customers, but the others are all to site B. Then you would need both transaction and request. So that's how you have to figure those out. Now for the week 5 answer 2 for the week 5 assignment. The following data structure and constraints exist for a magazine publishing company. And the company it has one regional magazine each in Florida, South Carolina, Georgia, and Tennessee. And they have 300 customers distributed throughout the 4 states listed in Part 2A. And on the 1st of each month, an annual subscription invoice is printed and sent to each customer whose subscription is due for renewal. The companies decided to decentralize. I'm going to let you read the rest of that. So each subscription site will handle its own customer and invoice data. So instead of all these invoices, subscription invoices being sent centrally, they'll be sent out by each division, however you break it up, state, region, whatever you want to call it. So, but you still have to have management have access to everything, because they print invoice data. They also list current customers. They list new customers. They do a report of all invoices. And with these in mind, you're going to first decide what each region should be, then determine if you how you should partition, whether vertically or horizontally. Vertically is by row, horizontally is by column. So for instance, if you partition a database table, vertically you're cutting off the bottom rows. If you do it horizontally, then you're keeping all of the columns and then deleting some and putting some of them, you're keeping all the rows, but putting some of the columns in another table. That's what partitioning is. So right now, they have all of the customers in one table, and we want to split it up. So you need to decide what your region is going to be. Then for 3, you want to answer these questions. What recommendations will you make regarding the type and characteristics of the required database system? So for instance, if you've already decided on your locations in the last one, are you going to fragment any of them? What's the node name going to be called? And what criteria must be used to partition each database? Design the database fragments and show an example with node names, location, fragment name, attribute names, and demonstration data. So for instance, if you have a customer, say this is your customer data, your customer table. Your customer has a number, name, address, city, state, and then subscription date. And then E is what type of distributed database operation will be supported at each remote site. You must first draw up a map of the locations, the fragments of each location, and the type of transaction or request support required to access. So for instance, if it's a customer database and it's only accessed locally, then you would only need local access. You wouldn't need distributed access, because you are only doing remote. You're not going to other. But then management has to have distributed access, because they access everything. Then what type of distributed database operations must be supported at the headquarters site? So if you look at the map you drew in E, and this is an example, just an example of what you might use for your map. Study for the quiz for week 5. Know what happens when a rollback is issued before the termination of a transaction. That's on page 489. Know what a lost update is, page 490. Know when uncommitted data occurs, page 491. Know what the scheduler does, page 494. Know the 2 states of a binary lock, page 498. I'm sorry. Know what database buffers are, page 506. Know what database checkpoints are, page 507. Know what a write-through technique is called, page 507. A foreign key attribute in one table must have values that match the transaction log in another table. Recognize a correct query, page 484. That's all I have for tonight. Oh, I'm sorry, I forgot about the final project. By now you should have completed your proposal document. Explain what type of database you're going to make. Explain what tables you're going to have. And then this is where you're going to take screenshots of your queries, any views you create. You'll paste them in this Word document. I expect at least 4 queries and at least 1 view. And they call it in the assignment stored procedure. It's basically a query. And that's what you're going to need to paste in your Word document. We'll go over more about it next week. That's all I have for you this time. Please let me know if you have any questions.